In this module, we're going to look at how to deploy SQL Server on Azure virtual machines. We're going to look at the process for doing this. We're going to talk about some of the benefits that Azure virtual machines provide us. We're going to look at the process for implementing those virtual machines, both from an image and building a virtual machine from scratch. We'll talk about some other methods that are available for deploying virtual machines in Azure that have your SQL Server. We'll look at the licensing requirements for Azure SQL Server and the different options that are available to you. And then we'll look at some of the options for migrating on-premise databases to Azure virtual machines. We'll look at some of the benefits of the different methods that are available. We'll compare and contrast the different options based on whether we can allow downtime or not allow downtime for migrating on-premise databases to Azure virtual machines. So another way of running SQL Server in the cloud is by running SQL Server on Azure virtual machines. And as we talked about earlier when we did the compare and contrast between Azure SQL Database and SQL Server on Azure virtual machines, you have a lot more control over the processes and over the servers. But again, you have to understand that that control comes with some responsibilities. You're now responsible for managing and maintaining all those virtual machines, including the operating systems and the applications, and patching and updating all those on those systems. So we can run SQL Server on Azure virtual machines, and we're going to look at many methods for actually deploying these. Essentially, there's two options here that you need to be aware of. You can use the SQL Server image that Microsoft provides, and in that scenario, you're being charged based on the time that the virtual machine is actually running. And that includes the SQL Server licenses, so you don't have to worry about licensing costs for SQL or Windows. You can also choose to bring your own license, and in that scenario, you bring your own license into the environment if you are a software assurance customer, and you don't have to pay the per minute use of the SQL Server. You still have to pay for the use of the virtual machines and the data that's coming in and out in the storage, but you're not paying for the SQL usage on a per time basis. Once you set up the virtual machines, you have to identify how the clients are going to connect to those virtual machines. If you're familiar with the SQL environment, the default port number that's used by SQL Server is port 1433. So you can have the clients connect from the internet directly on 1433. To do that, you're going to have to set up some firewall rules in your Azure tenant to allow those connections to those port numbers. You could also create web front ends. You can use Azure Web App to actually connect to those, and then you would use virtual networks to connect the Azure Web App to the SQL Server that's hosting the web pages. You could also choose to have your on-premise clients connect directly to your Azure environment, and for that you can use either VPNs to connect to that environment, or you can use, as we talked about previously, ExpressRoute. ExpressRoute lets you create a direct connection between your on-premise environment and your Azure tenant. You can replicate data between your Azure VMs and your on-premise VMs. Again, you can make your Azure VMs your subscribers that we talked about previously, and we can have the data be sourced from the on-premise servers and then replicated for decision support or for catalogs or things like that. We might manage the catalogs on-premise. We might allow people on the internet to search the catalogs. You can also do hybrid architectures where you have Azure servers as connections or components of on-premise servers. So we can do things like always-on availability, and we can have the servers in Azure running in the cloud that are receiving copies of the database, and we can fail over to those servers should we have an on-premise failure or a data center failure. They also mention in your text about there's some functions you have to do. You have to do extensions for SQL Server Agent in order for you to be able to do things like patching of your SQL servers in Azure, automatic patching of your SQL servers in Azure, automatic jobs of your SQL servers in Azure, and automatic replication for SQL servers in Azure. So you're going to have to extend the SQL Server agent on the virtual machines that are running in Azure to make them understand that they're in Azure. So there's some functionality that's going to work a little differently. In this demonstration, we're going to look at the process for provisioning a virtual machine in Azure. In this demonstration, we're going to look at how to create an Azure SQL VM So I've brought up my Azure subscription. So what I'm going to do now is I'm going to click on Add for a new virtual machine. And once the portal comes up, we're going to do a search for the virtual machine types. So we're just going to type in SQL Server, the current version we're looking for. And you're going to see right here we have an option to run different versions of SQL Server on different versions of Windows. So we're going to run this version here. And down here, you can't see it at the very bottom with the way our screen environment is set up. But right at the bottom, we have the deployment model, which we're going to use as a resource manager model. And we have a create option. So we're going to choose the resource manager option. And we're going to click create. So then once we start that process, we've got to give the details of the virtual machine that we want to create. Now, for labs, we're going to do things like this. And the green check mark means that that name is available. We're going to use SSD for storage, but just keep in mind that the higher level of the storage that you use, the more expensive it will be. We're going to specify an account that's going to be used for the administrator of the virtual machine. Wow, this thing really is slow. And a password to be used. Now again, you have to understand that in previous versions of the course, we would just use a simple standard password, but they don't let us use those standard passwords anymore. They've become too common. So we're going to use a resource group for this, and I'm going to create a brand new resource group for this because I don't already have one set up. SQL demo. And we pick the location where we're going to store our information. Again, a lot of times this will have an effect on the resources and the types of components that are available. So this right here is the bring your own license, all right? So that's the, if you already have a SQL license, you can bring that SQL license into the environment, or if you can also bring your own Windows license into the environment. So we'll click OK at the bottom. I know you guys can't see that on the screen, but it's just an OK button. There's really no magic to that. Now, after that part, what we're going to have to do is we're going to have to pick the size of the virtual machine. Now, this list right here shows you can see most of the information here about the size of the virtual machine that we're going to pick. And I'll scroll through so you can see. And what you're going to see is over that you can't see is the cost. How can I make you see this? Because that is probably the most important part right there. So if we get this over here, and you scroll out here to the right, this is probably the most important part that you need to keep in mind, which is how much you're going to pay on a monthly basis. That's US dollars per month estimated cost. So that's why the different versions matter here. All they're going to be is different sizes of resources allocated to the virtual machine. So what you can see here is when you pick the different kinds, you're going to actually see the different sizes here, and you can see the number of disks, but more importantly, it's things like the amount of memory, the number of virtual CPUs, the number of disks, the type of SSD storage that's automatically included. That is going to be what actually impacts the cost of the virtual machines. Too far over. And so these are the sizes here. So in the demonstration, they wanted me to pick the DS11 V2. Now, also keep in mind that these things change constantly. All right, so what's available changes drastically. So here's the star. See, that's a favorite. So that one has 4 virtual CPUs, 28 gigs of memory, 16 data disks with a max IOPS of 12,800, 56 gigs SSD storage. So you can see that's a lot. But notice the cost of it, $223.20 a month is the estimated cost. Now again, at the very bottom of the screen, which you can't see, there's just a select button. And I'm going to choose that select button to pick that particular machine that I want to deploy. Then we get to pick different settings, so we can set up availability sets, so we can have high availability for it. We can specify different storage options. We can specify virtual network. It's going to automatically create a virtual network for us for this. These are all going to get created in the same resource group. We can tell it that we want a public IP address. Here we can expand this out. We can actually configure the public IP address settings. So right here we can choose a public IP address. We can create a brand new one. We can specify details about that. So if we want to be able to connect to this from the public environment. And that's because I was closing the public IP address blade. We can configure NSG, Network Security Group, as firewall rules. So once we're done with configuring the settings, we click OK. Why is it? So we'll say no public inbound ports. And then again, notice we have a setting here for SQL Server settings, more settings for things like the connectivity. Remember, I chose no for a public. We have the port that we're going to use for SQL Server. That's 1433. These are all the SQL Server settings. The previous screen was the Windows settings. We can tell it when it's going to do patching. We can control backups. We can configure it as part of an Azure Key Vault, which allows us to encrypt our storage of all of our data. So we'll click OK for the SQL Server settings. This is our summary screen. Once we verify that everything is indeed what we wanted it to be, we click Create. And what that's going to do is that's going to create our virtual machine. Now you'll notice it's creating it on the dashboard. There's actually a checkbox for that. So it's going to create this on the dashboard. Once this is created, this is spun up. Now remember, basically what's occurring here is we are basically taking an existing virtual hard disk image that Microsoft has already created that has SQL Server on it, Enterprise Edition, and Windows Server on it. And we're just simply taking that VHD and creating a virtual machine from it. So we don't have to wait for the actual installation of the software. So we don't have to install Windows. We don't have to install SQL Server. However, we have to wait for the disk to get copied to our storage container that's part of our resource group. We have to wait for it to start up and initialize those for the very first time uses. So that's still going to take a few minutes. So I'm going to pause the video while this is going on. And once it shows me that my VM is available, I'll start up again and show you how to connect to that virtual machine. Okay, so my deployment has finally finished. It took about 10 minutes for this deployment to complete. And you can see that it automatically opens up a pane that shows you the properties of your resource. So you can see in here, there's another thing down here that shows you the disk operations that are occurring. But you can see, typically with Microsoft, 4 major categories: CPU, network, disk, and normally memory. We don't see the memory here. And then we also see up here the name of the virtual machine, the resource group that I created, the name of the machine right here, SQL 2017 BW1. And then notice here all the way at the top we have a connect option. So this is what we're going to click, and this is going to let us connect remotely, basically do an RDP connection to our virtual machine. This is how we would manage it. So we click connect. Now remember, we have to specify the name of the account that we used. So you can't really see this yet. I'm hoping to move this in so you can see it on the demonstration screen. There we go. So you can see right here, that's the public IP address that it has. And this is the RDP environment that we're going to connect to. Now we also have the option of connecting using Secure Shell, but we're going to use the RDP environment. So we will download the RDP file. And again, what you can't see on the bottom of the screen here, it's off your screen, but it just says, what do you want to do with it? I'm going to say open it. And so there's the RDP screen. So you can see there's the IP address we're connecting to right there. And we are going to, it's just a standard RDP thing. So we'll say connect. And then we'll type in the account that we specified when we created the virtual machine. Uh-oh. That's not good. Might still be spinning up. All right, I'm going to pause this again and take some looks at the VM properties. So to force the issue, what I did was I went ahead and created a firewall rule to allow port 3389. Eventually that should automatically open up and we shouldn't have to do that. But here's the account that we put in that we created earlier. So demo admin. We put in the password that we specified. This is a warning that the certificate doesn't match. And that's going to connect us to the virtual machine. So this is an RDP session, just like if you've ever done any RDP in your service before. It's going to be the exact same thing. The difference is that the hardware is running somewhere entirely different. So again, I know the screen size is stuff you can't really see, but all I'm going to do to prove that we have a SQL server here is open up SQL Management Studio. And again, I realize you can't see that, but you will notice it once I open it up. So I've launched the SQL Management Studio, so you can see in the screen it's the SQL Management Studio that we have. See if I put this in a window, if it makes it a little bit easier to see. A little bit, not too bad. It's still too big for what you want. But you can see it's loading the Management Studio for first time use. And then there's my connection screen. There's the name of the virtual machine that I supplied when I created it. And as you can see, we now have, well, it doesn't want to do that, so I'll move it over a little bit here. It doesn't want to do that. It just wants to anchor it to the left-hand side. But you can see right there, there's the objects that we have. It's basically a full-blown SQL server that's just running on somebody else's hardware out in the cloud. And that's how you deploy a virtual machine, a SQL Server virtual machine in Azure. In this demonstration, we get to see the process of how to provision a virtual machine in Azure that has the SQL Server service already installed on it. So as mentioned previously, when we talk about licensing for virtual machines that are running in Azure, it all depends on how you set up your SQL Server when you were setting it up on an Azure virtual machine. If you chose to use an image, a SQL Server image, from the Azure Virtual Machine Gallery, that automatically includes the licensing required to run both Windows Server and SQL Server running on that virtual machine. And you're billed and charged based on a per minute rate depending on the size of the virtual machine that you chose to create when you set it up. If you are a software assurance customer from Microsoft and you have a software assurance license for your SQL Server, you can bring your own license, build a SQL Server in Azure, and use the license that you already paid for your software assurance environment. If you're a Microsoft partner or Microsoft provider, you can also install and upload an image into Azure using your subscriber license that allows you to manage that server and install those servers in multiple places. You have to compare and contrast the costs here and look at the differences and how they apply to your environment to determine the best case for you. If you are not a Microsoft provider, then you're going to have to buy a license from a Microsoft provider in order to run that license on a SQL Server that's running in the Azure environment in the cloud. Most people are going to use the Azure Machine Gallery, and so the licenses are included based on the size of the machine. So if you remember, SQL Server is licensed per core. This does the core licensing based on the size of the machine. So the charges per minute go up based on the number of cores that the virtual machine is running. So one of the big advantages to using Azure virtual machines to host our SQL Server over Azure SQL Database is our flexibility and the high availability options that we have. So we have the ability to use the always-on availability feature of of SQL Server to host copies of our databases in virtual machines in Azure as well as in machines that are running on-premise. We can also choose to put these in separate data centers across Microsoft and Azure. We'll talk more about that a little bit later on. We can implement failover clusters in Azure and again on-prem, and that allows us to create full servers that replicate everything between the servers to the different components. One of the things to keep in mind when we talk about failover clusters is you have to have a shared storage environment, and that presents a little bit of a challenge when you talk about some servers that are running in the cloud and some servers that are running on-premise, but we'll look at this feature again a little bit later on as well. Availability groups in Azure allow us to reduce downtime by placing virtual machines in separate environments. So this is one of the important concepts. So if I decide to set up failover clusters in an Azure environment, I have to make sure that the nodes, if you were doing this in an on-premise environment, your own virtualized environment, you'd have to make sure that the nodes that were running in the cluster were on different Hyper-V hosts or different virtualization hosts. So that if you take one host down, you don't take down all of the virtual machines that are in the cluster. That concept in Microsoft is called fault domains and update domains. The fault domains have to do with the power source and the power system. So when you create availability sets or availability groups, they list them as here, they're actually called sets. When you create an availability set, you're actually specifying that these systems that are in this set will never be on the same fault domain and never in the same update domain. The update domain is servers within the same update domain will receive updates at the same time, which could require the servers to reboot, and if they were all in the same update domain, when we reboot them, we could end up rebooting all of the nodes of the cluster. So by defining availability sets, we make sure that the servers are always in separate fault domains, separate power, separate racks, if you will, separate data centers, and separate update domains so they don't all receive updates at the same time. By doing this, we make sure that there's always one server up and running at any given point in time. In addition, your text mentions the ability for you to configure backup functions within the environment. For that, we have to do the SQL agent extensions to allow us to configure the automatic backups. And once we do that, we can then configure the backups. We can only do backups this way if we're going to do the full recovery model for the database. So again, to provide disaster recovery for SQL Server that's running in Azure, we can set up always-on availability groups, which we mentioned in the previous slide, to allow us to create separate copies of the database across different Azure SQL servers. We can do that and by putting the Azure servers in separate fault domains, separate update domains, and making sure they're in separate data centers, which are called regions in Azure, across the world, to make sure that one data center problem does not cause issues with other virtual machines that we're running or other copies of our database. We can implement database mirroring. When we set up Azure virtual machines and we install SQL on them, we are actually getting a full-blown SQL server, so we have the ability to mirror our databases. Keep in mind that the mirroring concept is deprecated now, so a lot of products won't be using database mirroring in the future. The preferred option is always on. We can do backup and restore. We have full control over the server, so we can configure the backup and restore options, and we can back up our databases to Azure Blob Storage. And as I mentioned previously, in order to do this, the database has to be running in full recovery model, and we have to put in the SQL Server agent extensions in order to allow us to automate the backups. Once we install the SQL Server agent extensions, we can then go into the properties of the database and we can schedule the backups to occur on a schedule that we define. When you set up your SQL Server in Azure, you get the ability to turn on the SQL Server agent extensions. If you don't do it at that time, you can do it later by running the Azure PowerShell module to add the SQL Server agent extensions. So we can also control the patching of our SQL servers. For those that might be familiar with, say, System Center Virtual Machine Manager or products like System Center Configuration Manager, you have this concept of things called maintenance windows, where we can control when certain operations take place. And with System Center VMM, we can actually control when updates or patches are allowed to be applied to our systems. Well, that pretty much is the concept here. So what it allows us to do is it allows us to configure when the updates or the patches are allowed to be applied to the servers. And I can do this across different servers, especially servers that are in different data regions, or servers that are part of the same failover cluster, to make sure they don't receive the updates at the same time. When we do this, we have to configure the SQL Server agent extensions in order to do the patching. We can do the configuration of the schedule through the portal, or we can use the Azure PowerShell. Now, in this example here, you're seeing how to do it in the PowerShell. And what you're seeing is we're first creating a series of variables. This is going to be the name of the virtual machine. This is the resource group that it's in. And then we specify the schedule. Now, in this example here, we're actually creating a patching schedule. So you see that command right there? That creates a brand new Azure VM SQL Server auto patching configuration, or schedule is really what we're doing here. We're specifying this to occur on Sundays, starting at 3 a.m., running for 2 hours for important updates. Then, after all these variables have been populated, we run this Azure PowerShell command, set Azure RM VM SQL Server extension, so that's why we have to have the IAS extensions installed, auto patching setting, and then we pull in the schedule that we defined here. There's the schedule. We pull in the VM name from there, and we pull in the resource group name from there. And what this will do is set this schedule that important updates will automatically be applied to this virtual machine, my VM, for SQL, only for SQL, so remember this is the SQL Server extension, on a schedule starting at 3 a.m. and running for 2 hours. So starting at 3, ending at 5. Again, what this does is this allows the patches to be applied automatically without us needing to manually configure it or set up things like WSUS in our Azure services. So this slide looks very familiar, very much like the Azure SQL Database Options. We just have more options here than we have with Azure SQL Database in order to get data from an on-premise SQL server to a SQL server that's running in Azure. We could do a backup and restore, which you didn't see when we talked about Azure SQL Database. So we can back up a database on-premise using the compression option. Here, the main reason is because that'll make the data set, the backup file, smaller, so that we copy that to our virtual machine. We remote desktop into our Azure VM. We copy it to a disk on that Azure VM, and then we run the SQL Server restore method. When you do the restore, you're going to have to use, usually with replace, but you're also going to have to specify the move to options because you're actually storing it in a different place now. We could do a backup directly to an Azure Blob Store and then use the Azure VM to connect to that Blob Store and do a restore directly from that Blob Store. This cuts out the manual process of copying the data from the on-premise environment to the Azure environment. We could detach the database, copy the database files to the Azure Blob Store, and then attach the database files from the Azure Blob Store to the Azure SQL VM. We could convert the server to a VHD completely, the entire server, migrate the server or convert the disk into a VHD, and then copy the VHD into Azure and then build a new VM and attach the VHD to the VM, and that would become our new server, and everything that was on it would be on that server. We could also use a feature called the Azure Import Export Service, where we could copy the data that we need. And this would be if you wanted to do lots of databases. We would put those databases on a single disk, removable storage of some variety. We would send that removable storage to Microsoft. They would then add that removable data to our Azure storage account. And then we could access the data from our Azure storage account. All of those methods are going to involve some downtime. If we want to minimize downtime, two options we have. One is to use Azure VM replicas, so Hyper-V replicas, and create a replica of a VM from an on-premise environment to the Azure environment. And then once that replica is created, we can then copy the data. So we can use the SQL Server Always On replica to the machine, or we could use, if we had Hyper-V on-prem, we could create a replica of the virtual machine in Azure and then automatically just switch over to the copy. That switchover is going to have minimal downtime. It's going to be more than if we use transactional replication, but it's not going to be a lot. It's going to be a lot less than the migration methods mentioned previously. And as we talked about earlier with Azure SQL Database, we could set up transactional replication. The difference here is the distributor role here can be in Azure, unlike with Azure SQL Database where it has to be on-premise. So again, what we can do is one method is to do backup and restore. What I would caution you about here is if you're going to back up this database, make sure you take the database offline so that nobody's in the database and there are no changes, because you're creating a snapshot in time, and when you restore it, if any changes occur after this, those changes will not be included in your Azure copy. So think about that. But you basically back up the database like you would back up any other database in SQL. So here's a standard backup command in SQL Server. Backup database, the name of the database, to disk, the disk path. Now, what I would reference right now is, notice they mentioned down here we could back up to a blob storage account. Right here, this would have a URL, which would be the URL of our blob storage account. With compression, the format's just going to, if there's anything else in this file, it'll overwrite it. We give it a name. This is going to be for migration. That's the media name that it's going to create for this file. We give it a name for the backup right there, and then we run it. All right. So what that's going to do is it's going to create a file called adventureworks.bak in the d:\backups folder. I would then copy that. It says database. I don't like that. I would by by RDPing to the virtual machine and then copying it to a local store for the virtual machine. And then in SQL, and the text is, the transact SQL statement is in your text, you could go into the SQL server running in Azure and run the restore database from disk. You'd reference where you copied it to. You'd say with replace, move the name of the data file to the destination of the new data file. So that would then allow you to restore it. It's important to note that I could also use the SQL Server Management Studio connected to the Azure virtual machine and restore it from there by clicking on the disk option and then pointing to the place that we copied the file to in order to restore it. So a couple of different options. Again, the backing up to the blob storage account is just simply going to have a different URL right there to back it up to that location. So as of the time that this courseware was written, there's a wizard that we have in the SQL Server Management Studio that will automatically deploy a database to an Azure VM. Now, the SQL already has to be installed on that Azure VM, but what it will do as part of a single process is it will, you'll walk through the wizard, you'll identify your Azure VM, and you'll get the option of telling it that you want to create a new VM, and it will automatically create the VM, create SQL on the VM. It's going to use an image from the gallery, and then it will automatically restore your database on that version of the SQL Server that's being created. You can also tell it to use an existing VM. There are some limitations to that that are listed in your text. Specifically, there's an odd port number that you have to configure that has to be configured. So it's port 11435 has to be configured open between your on-premise environment and your Azure environment in order for you to use an existing SQL server. So what it does is it first creates a compressed backup like we talked about previously. It then uploads the file to Azure like we talked about previously, and then it restores the backup file to a new database in the Azure VM. So you can see it does everything that we talked about how to do manually, it just does it for you automatically. The reason I mentioned that as of this writing is because, strangely enough, this wizard only works with Azure VMs that were created in the classic deployment model, not the resource manager model. So all of the components, the Azure storage account, the Azure VM, all have to be in the same region. That's what they used to be called before, Azure regions. If you've created your VMs using the Azure Resource Manager model, you can't use this wizard. I'm hoping they're going to update this wizard shortly to support the Azure Resource Manager model. In this demonstration, we're going to look at how to use backup and restore as a method to migrating a database to Azure.
In this demonstration, we're going to see how to get data into a SQL Azure VM using a backup of an on-premise SQL server. Now, in the previous module, we looked at how to get data from an on-premise SQL server into Azure SQL Database using backpacks. Here, we're going to look at how to use a backup of an on-premise database and use that to restore that data into an Azure SQL VM. Now you'll notice that down here my RDP session is still open from the previous demonstration I did where we set up the Azure VM. So now what we're going to do is we're going to come in here and first we're going to look at the data that's in the database that we're going to back up and restore. So what we're going to do is we're going to show the data from the HR employees table. So we'll click here, HR employees, we'll right click, and we'll say select top 1000 rows. And as you can see, there's our rows. We have 9 rows in that table. And we're going to compare that later once we get the data copied over. So what we're going to do now is we're going to create a brand new query. So we're going to create a new query here. Why? That was really weird. New query. And we're going to use the example DB. and we're going to back it up. We're just putting some information in here so when we look at the backup details, we will know what the purpose of this backup was for. So we will highlight this. Let's make sure I didn't type in anything incorrectly. It looks good. We'll execute that and it backs it up. Now notice it's pretty small. There's really not much in this database. So then what we're going to do is we're going to come over to the file system and we're going to go to that location where we send our backup. And there's our example backup, and we're going to copy this. So then in our RDP session, which is where our live virtual machine is, we're going to go to the file system here, and we are going to paste in the file to the root of the C drive here. Now keep in mind in real life, this is likely to be quite large, so this could take some time. Right, but for the purposes of our demonstration, it's pretty small. Obviously, this is going to depend on all kinds of factors like your internet connection and all kinds of other things. So now that we have that database backup copied here, we can go to our Management Studio, which again, we already have open here, and we're going to restore a database. So we're going to restore the database, and we're going to restore the database from a file. Okay, so what we're going to do is we're going to come in here, and we are going to type from device, and we're going to specify the file. We're going to add the file from the root of the C drive. Scroll all the way up, click on C. There's our example DB backup. We'll click OK. We'll click OK. This is the way I would do it. They want me to do it through Transact SQL. So I will go ahead and demo it through Transact SQL. I will demo it through Transact SQL the easy way by copying it. So we will copy this data. Perhaps. Let's see if we have it here. Let's minimize our RDP session. Nope, it's not there. For some reason, there we go. Okay, so now we'll go back over to our RDP session. We will click in our window here. We will go to Commands, Paste, Clipboard Text. We'll paste in what's in our window, click OK. So you can see we're going to restore the database, example DB, from disk, and we're going to use the with replace option, and we're going to use the move to option. The move to is required because we've got to put it in a different location than it originally resided in. So we will go ahead and parse that, make sure it doesn't have any problems with it. We'll go ahead and execute it. And now if we come over to databases, what we should now have is an example DB database. There's our example DB database. And again, if you remember in the tables, we went to HR employees. We said select top 1,000 rows, and there are 9 rows. So that is how you can back up data in an on-premise database and then restore that data into a SQL Azure VM.
In this demonstration, we got to see the process of backing up and restoring a database from an on-premise environment and then restoring that database to an Azure SQL Server. In this lab, you're going to deploy SQL Server on an Azure virtual machine. You're going to start off by deploying a virtual machine in Azure that's already running a SQL image. Then you're going to take backed up copies of databases from an on-premise SQL deployment and you're going to restore them in your Azure virtual machine. You're then going to configure your connections to allow you to manage your SQL Server instance that's running in Azure. This lab should take about 45 minutes.